This is a homework help video for Advanced Algebra, Chapter 9, Lesson 1. We're going to look at 6 problems or so. First one being number 14, ask you to simplify. When I simplify, I'm looking for terms that are able to be canceled. In number 14, I have b's in the numerator and b's in the denominator. So I can cancel them out. Only one of the denominators is going to cancel. So I'm left with 30c over 12b. But I also have to look if I can simplify the numbers. 30 and 12 are both divisible by 6. So if I take 30 divided by 6, I get 5. I take 12 divided by 6, I get 2. So there's my simplified answer for number 14. Number 20, same directions, but I have a polynomial instead of monomials. When that happens, I see if they are factorable. Is my numerator y squared plus 4y minus 4 factorable? The answer is yes. I'm able to break that into 2 parentheses. The quantity y plus 2 times the quantity y plus 2. I do the same thing to the denominators. 3y squared plus 5y minus 2 factorable. Maybe you know the diamond method. Maybe you just have to guess and check. Either way, it is factorable into 3y minus 1 and y plus 2. Now that it is factored, I cancel any terms that are with numerator and denominator. Like, I got a y plus 2, I got a y plus 2. Whatever doesn't cancel is your answer. Y plus 2 over 3y minus 1. There's our solution for number 20. Number 30, asks you to multiply. Before I even multiply, I again, just like the previous problem, try to factor. I look for GCFs to begin with. And I notice that in the 2 numerators, the 4t squared minus 4 and the 3t plus 3, GCFs. 2t minus 2 in the lower right-hand corner of the problem, also GCF. So the first thing I'm going to do is just factor out GCFs. And there's my new numerator for the first fraction. I'm going to leave the denominator alone. There's no GCF for that for the time being. My new numerator in the second fraction will be that. And my new denominator in the second fraction will be that. Now that I have taken all my GCFs, I will look if there are any factor patterns. Like I notice in this parenthesis right there, t squared minus 1, that's a difference of 2 squares. I'm going to factor that using that factor pattern, which means I can rewrite it as t minus 1, t plus 1. In my denominator, I see that I have the quantity t plus 1 squared, so I'm going to write it as t plus 1 times t plus 1, 2 of those terms. In my second fraction, there's nothing else to factor. We took care of everything when we did the GCFs. Now that everything is factored, everything is expanded as much as possible, I will cancel anything that can cancel. Like I have a t plus 1 in a numerator, t plus 1 in the denominator. I got a t minus 1 in my numerator, I have a t minus 1 in my denominator. A t plus 1 in my numerator, t plus 1 in my denominator. Everything is canceled except my numbers. If I multiply my numbers just the way they are, 4 times 3, 12, 9 times 2, 18. I'm not going to leave it as 12 over 18. I'm going to simplify it. I'm going to use my calculator or use my brain and think about what numbers are divisible into 12 and 18. And I will end up with a fraction 2/3. That's my simplified answer for number 30. Number 34 almost looks like the previous problem, except it's division instead of multiplication. So before I do anything, I'm going to rewrite this problem as a multiplication problem, which means nothing changes in my first fraction, but I'll change to multiplication by taking the reciprocal of the second fraction. I flip it. Now that I got a multiplication problem, I'll go through and I will look for GCFs, or I will try to factor. I'm going to do both of those at the same time. My numerator, right there, is it factorable? Can I break it into parentheses? Well, is there a number I can multiply to get -8, add and get a +2? Well, sure. R plus 4, R minus 2. I look at my denominator, this one. R squared plus 4R plus 3, is that factorable? Numbers I can multiply to get 3, add to get 4. R plus 1 times the quantity R plus 3. In my second fraction, I don't have trinomials, but I do see I have 3R plus 3, where is a GCF. I can take a 3 out of each term and end up with R plus 1. My denominator for that one, there is nothing to factor. It is R minus 2, and I'm going to put it in parentheses just for the consistency's sake in the visual. I try to cancel. I think I can cancel. I got an R plus 1, R plus 1. I got an R minus 2 in a numerator. I have an R minus 2 in my denominator. I have canceled everything that I can cancel. So what's not? Well, my numerator, I have the quantity R plus 4 times 3. In my denominator, I have the quantity R plus 3. Now, depending on your instructor, maybe you can leave it like that. If not, in my numerator, I'll distribute the 3 and get 3R plus 12. My denominator, there's nothing to do other than write down R plus 3. And there's my answer for number 34. Number 44 and 45 are story problems. Number 44 asks you to write a fraction to represent the ratio of field goals made to field goals attempted. Well, in the directions above number 44, it says that he made 6,827 field goals. These are makes out of 13,129 attempts. That's all there is for 44. Number 45 says, suppose he attempted A field goals and made N field goals during the 2001-2000 season. Write a rational expression to represent the number of career field goals made to the number of field goals attempted. Well, he already made 6,827 before that particular season, and he is going to make M more. He already attempted 13,129, and he is going to attempt or shoot A more shots. And that's all you need to do for number 45.